Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in this video, we will talk about today's daily challenge on Leetcode, and we will solve it in two methods, O of n log n and 2 O of n also. And during this approach of this, I will show you a neat trick where you can sort an array in O of n. So if you are just confused and just thinking that I'm talking something rubbish and all, because O of n sorting is not taught in something in the theory books and also, so it is possible for this problem. Okay, it is possible, and I will also show you the complete code of how and in which cases you can sort the array in O of n time, and it will be very interesting. It will be very interesting if you already do not know such methods. So stay till the end of the video and I will explain you in detail. So let's try to read the problem first. uh, Partition array such that maximum difference is k. You are given an integer array nums and an integer k. You may partition array into one or more subsequences such that each element in nums appear exactly one of the subsequences. So you need to return minimum number of subsequences needed such that the difference between the maximum and minimum values in each subsequence is at most case. Okay, so you are dividing the nums into some subsequences, and the minimum and maximum difference in those subsequences, you are only bothered about that. And you don't want that to exceed k, and you want to tell that in how many ways can you divide the subsequence. How many ways can you divide the subsequence? So if I take this example, 3 6 1 2 5 and k equals to 2. So if you take this example of 3 6 1 2 5 and k equals to 2. The thing which they are doing here is they are taking 3 6 or 3 1 2 as a subsequence. So this and this as a subsequence they are taking, and you see that in this the maximum and minimum difference is just 2, so it is just on the boundary line, and the maximum minimum difference here is 6 and 5, which is 1. So it satisfies the condition that this should be always less than or equal to k, which is 2 here. So this such kind of subsequence division satisfies. But now you must think it while approaching is that what is all that matters in a particular subsequence. Suppose you select some subsequence, okay, and you select suppose 3 subsequences. What is all that matters? Only the maximum and minimum difference is matters. Okay, the maximum minimum here, the maximum minus minimum here. So does it matter in what way we arrange the numbers? Does it matter in what way? So here the maximum minimum is 3 1 2. Okay, if I do something like 1 2 3, or I do something like 3 2 1, still the maximum minus minimum criteria is still valid. Okay, still it is the same thing. It does not violate anywhere. So what can you understand from this? So no matter what is the order of the element selection from the array, it does not matter. Okay, so what the subsequence means here, 3 1 2 is a subsequence of an array, but 3 2 1 is not a subsequence. But you got to know that the order does not matter. So the word subsequence in this question is completely irrelevant. It's completely irrelevant. You can simply sort the array. Okay, for your benefits, for your own benefits, you can just sort the array. Okay, so if you sort this, it will become nothing like 1 2 3 5 6. Okay, and if you are not violating anything, because you just now proved that the subsequence does not matter, the order of the subsequence does not matter, and I can select numbers here. So why exactly I did I sort? First of all, that reason is there, but here is the thing is that return minimum number of subsequences needed, right? So how will that be minimum? So it's very simple. We can do a greedy approach. We can keep a pointer, let's say p here, okay, and we will start iterating from the left, I equals to 0 to n minus 1. As we go here, we check nums of I. If this nums of I is this minus this previous one is greater than or equal to is greater than n, is greater than k. Okay, k is 2 here, right? So is 2 minus 1 greater than 2? No. So we move to the next element. Then again 3 minus 1, is it greater than 2? No. So again we move to the next element. So maximum number of elements we are trying to accumulate starting from 1. So you can understand that only happen when the array is sorted. Okay, when the array is sorted, let's say this is a graph where x-axis is the index and y-axis is the nums of I. So I can accumulate the maximum number of elements with the difference only if I start from the sorted manner. Okay, so if I am going to 5 now and checking that 5 minus this previous pointer is exceeding, right? 5 minus this 1 is 4, which is exceeding k. So now I need to divide this into two subsequents. So I place a boundary here, and how do I know that I place a boundary here? I just put the p pointer, I just jump my p pointer to I. I just jump my p pointer to I, and the similar things I tried to do now. 6 minus 5 I check, because 5 is now the p. So 6 minus 5 I check 1, which is less than or equal to k. So that will also come in the subsequence. And initially our answer will be initialized to 1, because the whole array we can always select. So one subsequence is always there. And whenever we are jumping this pointer, whenever we are violating this k and jumping this pointer, we will increment our answer by plus plus. Okay, we can increment our answer by plus plus, and that's all. We can just see out our answer or return our answer, right? So that's all. It's a quite medium easy kind of problem, you can say. But this is an O of n log n solution. So let me just try to put it out quickly. You can see it. Now we need to sort this. I am using the inbuilt sort function. You can use it in any of your libraries, whichever function you are using, whichever coding language you use. So you have a pointer, as I told you, which will be initialized to the first number initially. Okay, you have this pointer, and as you go from I equals to 1 to n, as you go from I equals to 1 to n, you just check that is the current number minus the previous number exceeding k. Is it exceeding k? If it is, then you update your p pointer. And you also do answer plus plus. Okay, you also do answer plus plus. Why you are doing this? Because you are taking a subsequence. If it is not, if this criteria is not valid, means I do not need to update the p pointer. My single subsequence, that is only my single subsequence. Okay, so you have a answer here also, 1. So you just return answer. That's all you need to do. If you try to submit this, then you see you have the accepted thing. Try to submit it completely. If you check, and to check that whether you have the completely accepted thing or not. So yeah, you have it. This is a good method actually. But here you see there was only, I mean, there were if you see the submission, there were only 92 cases. So maybe not very difficult or not very long test cases are there. So an n log n solution is valid here. It's completely valid, and they expect you to solve it by that only, because generally they don't expect you to sort an array in O of n. So now comes the interesting part of the video. How do you sort this array in O of n? If you look at the constraint, first of all, this is only possible when each array is not 1e9, it is 1e5. Here you see the each array number is 1e5. Then you can do something known as counting sort. Okay, so it's very interesting. So first of all, it's a good interview question also. If someone asks you in the interview that you are given an array nums, okay, you are given an array nums of length n, where n is 1e5, and nums of ith element is also less than equal to 1e5. And if the interviewer asks you, show me 3 methods. So first, how you will sort the array in O of n square. Then you can look of some bubble sort or something. How you will sort in O of n log n. You will think of some merge sort or something like that. And if he then again asks you how will you sort this array in O of n, you may get completely confused, thinking that it is not possible at all to solve this array. But what you can do is you can count the frequency of all the numbers. So what you do here, you write a you have a count map. You create a map where index, see, the ith number goes from 0 to 1e5, right? 1 to 1e5. So you keep an index. You in the indices you treat them as their numbers. Okay, 1e5, and you store the frequency of all those numbers. So when you are iterating through the number, you're iterating to the nums of I. What you do is that you just store the frequency of this. Okay, so what you do, the count of nums of I, you do something like this. You treat that value as an index and store the frequency. You treat that value as an index. So if you have something in your array like 4 4 6 and then 9 and then 7 7. If you have something like this, how will you sort it? You store in something like 4, the count of 4, you store it as 2. Okay, the count value is here, nothing but. Okay, this is the indices. These are the indices I that I've written. The 4 count is 2. You can store the 6 count as 1. You can store the 7 count as 2. You can store the 9 count as 1. And then you simply iterate through this count. You just iterate through this count. If these values are not 0, you just have a sorted array. You just have a sorted array in which you push back this count number of times. So if you iterate, you encounter something other than 0, you push back the index. You push back the index that count number of times. Then you push back 6, then you push back 7, then you push back 9. Okay, so I am going to show this you in code also. So if you think this method is interesting and you did not know about this earlier, so definitely try to write it in the comments, right? Whenever you see something like 1e5, you can sort an array in O of n also. So that's the trick. That's the trick here. How will I sort this array in O of n? I remove the sort function and I will just manually sort it. I use a vector count which is using as my map, which will be of length 1e5 plus 1. Let's say. And you go through all the numbers in nums. Okay, you go through all the numbers in nums. And what you do is simple. You store the frequency. So it is similar to a frequency map. You store all the numbers, the frequency of all the numbers. Okay. Initially everything is initialized to 0 only by default. That's the thing in C++. Initially everything is initialized by 0, and I'm incrementing, so I've got the frequency. So I have a sorted vector now. I have a sorted array. I will push back into this array. I will just do starting from 0 to 1e5. Just go through this. And what I will do is count of if count of I is not 0. If it is not 0, then I will just push back this count of I number of times. This will not exceed O of n. If you try to think of even in the worst case, it will not exceed O of n. So while count of I is positive number, you just push back the sorted dot push back the index, right? The index which you treated the number as an index here. So you are pushing back the index. Okay. So you do have the sorted array. You do have the sorted array. And this array, you are instead of nums, you want to treat this array as the sorted, right? Okay. You do have, now you see you have the array sorted in O of n. Can we do anything more better? So a little bit more optimization is possible. So first I will run this and show you, and then because every time it is going till 1e5, but that you may not need all the time, right? That you may not need all the time. So you have a good runtime complexity, but you are using a lot of memory, a lot of arrays you are using. So one thing you can do is that you know that the number nums of I, this index cannot exceed the maximum element, right? So you just calculate the maximum element. If you just look to calculate the maximum element in nums, right? You just look to calculate the maximum element. You store it in this manner, max of comma x, and instead of this 1e5, because that number cannot go till maximum, right? I am just blindly putting the upper bound 1e5. Instead of that, if I put the upper bound as the maximum number, then also it is okay, right? Then also it's completely fine. It's completely okay, and it should give a better runtime complexity even now. In Leetcode, these things are pretty random. So it may not show you something very better, but yeah, this is the most optimal one. If you see, it is showing you, in fact, it is showing you 97.32% beats. So that's quite good. In some other run, it may show you even 100%. So yeah, you see, this was definitely an interesting method to sort the array in O of n time if the conditions are given in that way. Okay. So that's all for the video. This is a Leetcode medium video for Leetcode medium problem for today, but I hope your day is going to be really easy. So thank you so much. Thank you so much. Do comment in the comment section how you like the method, whether you knew it from earlier or not. And yeah, definitely subscribe to my channel. Thank you so much.